Welcome to today's video on measures of position. Measures of position are quartiles, percentiles, and even z-scores, but z-scores we'll talk about more in the last unit. And what they do is they illustrate where a piece of data is in relation to other pieces of data. So they're not talking about the central pieces of data, they're just talking about where individual pieces are in relation to others. They are illustrated using box and whisker plots. So let's take a look at this example. The ages of 15 people at a party are as follows, right here. And what we're going to do is create what is called the 5-number summary. You're going to see this terminology used a lot, so you need to know what those 5 numbers are. The 5 numbers are the ones that are in circles or ovals here. The maximum, the minimum, the median, which you should all know what all 3 of those things mean. The biggest value, the smallest value, the middle value. And then there's going to be 2 more that you're going to learn in today's video, which is the lower quartile and the upper quartile. So let's show you how you do that. The very first thing you do is you put this data into ascending order. Once you have your data in ascending order, we're ready to begin. So first and most easy is the maximum and the minimum. So the maximum is the highest, which is 56. And the minimum is the lowest, which is 3. Now the median, you should already know, is the middle value. And of course that divides the data into 2 equal sets. So since there are 15 pieces of data, the median, so the mth position is, there's 15 pieces of data plus 1 divided by 2, which is 16 over 2, which is the 8th number. So 1, 2, 3, 4, 5, 6, 7, 8. So this here is the median. Remember that if there is an even number of data and there are 2 middle numbers, you would have to take the mean or the average of the 2 middle numbers, and the median would be in between. So our median is 23. So those are the first 3 of the 5-number summary. Now the lower quartile, it's also called the first quartile, and its notation is a capital Q with a subscript 1. And what it is the median of the lower half of the data. So if we go back to our data, to find the lower quartile, what we're going to do is just look at the lower half of the data. So it's all the data below the median. There's 1, 2, 3, 4, 5, 6, 7. So its position, you find it the same way. You just sort of pretend that the top half of the data doesn't exist. So we have 7 pieces of data below the mean, plus 1 divided by 2 equals 8 divided by 2, which is 4, which means the lower quartile is the 4th piece of data. 1, 2, 3, 4. So that number there is Q1, the lower quartile. So the lower quartile was, what was it? It was 12. Similarly, the upper quartile is the median of the upper half of the data. Now, you're going to use the same position number. So you're going to use the same position number, but you're going to count this from the right side. In this example, doesn't make that much of a difference, but in harder examples, it would make a bigger difference. So 1, 2, 3, 4. That there is the median of the upper half of the data, so that is the third quartile. Okay, and you could have counted from the left, 1, 2, 3, 4, but my worry is always that you're going to start here and go 1, 2, 3, 4 and get the wrong number. So I usually like to start counting for the lower quartile on the left and start counting for the upper quartile on the right. So the upper quartile is 29. So that's 29. And again, remember, if there's an even number of data for your quartiles, you will go in between the two middle values. Now, the box and whisker plot is a way for you to illustrate the 5-number summary. And it shows the shape of the distribution. When it talks about showing its central value, that's the median, not the mean. And the variability. So we're not talking about the variability like the standard deviation around the mean. We're talking about the variability around the median. It's also especially useful for indicating whether there are potential outliers. Right now, it is a judgment call on your part whether something is an outlier. Later on, you'll learn a formula to decide whether something is an outlier. So here's how you draw a box and whisker plot. So over on the left, your lowest observation is your minimum. So our minimum was at 3. So you're not going to draw it right on the number line. You're going to draw it a little bit above the number line. And our highest observation was 56. So we're going to draw that here. And then what you're going to do is draw a line that is going to join those two together. Yeah, that line doesn't have to be quite that thick, so let's make it a little bit thinner. So you're going to draw a line joining the minimum and the maximum. Now the next thing you're going to do is you are going to draw a vertical line where the median is. All right, so the median was at 23. So at 23, and it doesn't have to be a big vertical line, just a small one. So a vertical line at the median. You're going to draw a vertical line, same length, at the lower quartile, which was 12. And another one at the upper quartile, which was at 29. And lastly, you seal Q1, Q3 with the median in the middle around a box. So there's the box. So you can see up here, there's the box. There's the whiskers. So in this, right here is the min. This line here is Q1. This is the median. This line here is Q3, and this line here is the max. So this gives you some information that tells you exactly how the data is distributed. You can see here, this is from the min to Q1. This is the first quartile. From Q1 to the median is the second quartile. From the median to Q3 is the third quartile, and from Q3 to the max is the fourth quartile. So this would tell you that the data is most spread out in the fourth quartile. It does not mean that there's more data in the fourth quartile, because remember, the quartiles divide the data into 4 equal sections. It just means that the data is more spread out in the fourth quartile, and it's more clustered in the third quartile. Now you might say that the reason why it's so spread out in this fourth quartile is because that number of 56 might actually be an outlier. So in a case like this, what you can do is what is called a modified box and whisker plot. So in this example, you would still put a dot on the min, and you would still put a dot on the max. But if you think this is an outlier, then what you would do is not extend the whisker all the way to this point. What you would do is extend the whisker to the next point before that, which was 40. So in that case, when you go to make your line, the line is going to go from the min, not all the way to the max. It's going to go to the next highest point, and then that point standing out there alone will indicate that that is considered an outlier. And then once again, you would draw your lines for your Q1, your median, and your Q3, and it doesn't matter how big those lines are, and then you put the box around it. So that is your modified box and whisker plot. So this one is called modified. And it includes the outliers. And the outliers may be on this side and they may be on that side, but that single dot right there is indicating an outlier. So as we said, we are using quartiles to measure your position, and it is your position against other people. So for instance, if you were 10 years old, that means you would be in the first quartile, which would mean you're in the lower 25%. So it may not matter what the ages are, you would just find out what that first quartile is, and that would be your lower 25%. If you were age 20, that would mean you were older than 25% of the people, but younger than 50% of the people. So you'd be in the second quartile, so you'd be between 25% and 50% of the people. And if your age was 50, that means you'd be in the upper 25% of the people. That would be the fourth quartile. Quite often, as an example, when you write a math contest, they give certificates to people who are in the top 25%. So what they're looking for are the people in the upper quartile. So that's an example of where quartiles are used. They would find out what Q3 is, and then anything above the third quartile, they would give a certificate to. So that's what quartiles are used for, and that's how you make a box and whisker plot. The box and whisker plot shown down here is another example of a modified one. In this case, they use a star instead of a dot for the outlier. A star, a dot, it doesn't really matter. Usually when we use Google Sheets, they'll use a dot. So if you want to use a dot or a star, it doesn't matter. If we go back to where we talked about box and whisker plots, 3 plots. We started off with this. The ends of the boxes are Q1 and Q3. That's the end of the box. Q1 or Q3 minus Q1 is what we call the interquartile range. And do remember that for later on, because that will come into importance later on when we get into calculating outliers. So when we talk about the interquartile range, you take the value of Q3, subtract the value of Q1. And the median is marked by a vertical line, and the whiskers are the two lines outside the box that extend to the highest and lowest observation. So that is your box and whisker plot. So the next thing we're going to go over is z-scores, and we're just going to briefly touch on this because z-scores are covered in more detail in the last unit. This says determine the z-score for Ganeek, who is 40 years old. So 40 is represented by the x in the z-score formula. So the x here is the piece of data. The x with the bar on top is the mean. The s is the standard deviation. And the z is what we call the z-score. Now, to be able to calculate a z-score, you would have to know the mean and you would have to know the standard deviation. You would be able to calculate those based on our data and based on previous lessons. So the z-score, and then we put a little subscript here down here for Ganeek. The z-score for Ganeek is her age minus the mean divided by the standard deviation. Now, when you go to calculate that, make sure you press equals before you divide by 14.51, and you should get 1.24. So for rounding, make sure that you round to 2 decimal places. So the z-score, what it does is that it measures how far away you are from the mean in terms of a standard deviation. So if a standard deviation is 14.51 years, she is 1.24 standard deviations above the mean. And this may not make sense right now, but later on when we get into future units, this will make more sense. So that means if you wanted to check this out, see if it worked. Ganeek is 1.24 standard deviations above the mean. So if we took the mean and we added 1.24 and we multiplied it by what the standard deviation is, which is 14.51, we would get her approximate age. And the reason it's approximate is because the standard deviation was approximate and the z-score was also approximate. Sorry, these should have been approximate signs. So that's what it means. So a z-score is a statistical measurement of a particular datum, that's a piece of data, its relationship to the mean in a group of data, and the units are standard deviations. A z-score of 0 means the score is the same as the mean. A z-score can be positive or negative, indicating whether it's above or below the mean and by how many standard deviations. So because it's positive, she's 1.24 standard deviations above the mean. And for some people, the purpose of doing this is there are different ways of figuring out whether something is an outlier or not. Some people's opinion is that if your z-score is above 3 or below -3, then that piece of data is considered an outlier. So that's one of the reasons why we calculate z-scores. That is not the only way that we calculate the outliers, but that is one way that they do. So that's one of the purposes of z-scores. You'll learn some of the other purposes of z-scores later on in future units. And the last thing that we're going to be calculating are percentiles. Now, there's something here to note. There is not one universal definition of a percentile, nor is there one universal formula to calculate them. What I'm going to do is give you the formula and the definition that is used in Google Sheets and Excel. So when you do your homework, this is important, your answers may be slightly different than the textbook. But what I'm going to do is give you the formula and the definitions that work with Google Sheets and Excel, because people do define it differently and calculate it differently. So the pth percentile, so let me use a number like the 95th. The 95th percentile of a set of data is a number such that 95% of the data is less than or equal to that number, and 100 minus 95 is 5% of the data is greater than that number. So let me show you this in an example. Let's say that on a test you got 85 and you were the 95th percentile. That means 95% of the class scored less than or equal to what you scored, and only 5% of the people did better than you did. So that's what a percentile means. So please do make sure, because on tests and quizzes and exams, there are sections where you have to explain what a percentile means. So what we're going to do is use the same data about the ages, and we're going to determine the 80th percentile. So if you remember from our very first part of this lesson, we were looking at the ages of 15 people at the party. So what we're going to do is calculate the 80th percentile. And here's how you do it. This is the process. And remember that you will get the formulas on the test. You will not be told what the letters mean, but you will get these two formulas on the test. So the first thing you want to do is order the n pieces of data from lowest to highest. We've already done that. The next thing you have to do is calculate the rank. So the rank is equal to 1 plus P is the percentile, so that's 80, we're doing the 80th percentile, times n minus 1. N, we had 15 pieces of data, minus 1 over 100. So this is the first formula that you need to work out. So when you calculate that, you get 12.2. So you're going to get a whole number and you're going to get a decimal. The whole number here is the I. The decimal is called the D. So the I is the integer part of the ranking and the D is the decimal part of the ranking. So to find the value, what we're going to do is we're going to take yi. So that means the observation at rank I. So I is 12. So that means we are going to take the 12th number. So if you go back to our ranking, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is yi. That is the 12th number in the ranking. So that's 29. So I is equal to, y1 is equal to 29. Plus D, which is 0.2 times y of I plus 1 minus y of I. So I plus 1, we found out that I was 12, so yi plus 1 is the 13th piece of data, and yi was that 12th piece of data. So what we're going to do is take the 13th piece of data and subtract the 12th piece of data. So this is yi, which makes this yi plus 1. So the 12th piece of data is 29 and the 13th piece of data is 39. So that's going to be the 13th piece of data, which is 39, minus the 12th piece of data, which is 29. So basically that difference is 10. And when you calculate this, you get 31. So the 80th percentile is 31, and that's years old. Okay, so what does this mean? That means 80% of the people at the party were 31 years old or less. Or you could say younger. It's a funny looking S, but that's an S. So that's a percentile. Whatever you get as the percentile, that percent of the data is less than or equal to this number. And to relate it to the context, 80%, the context was the people at the party, were 31 years old or younger. And that's how you calculate a probability, percentile, sorry. The second part to percentile is, well, the first part was if you know the percentile, what's the value? The second part is if you know the value, what's the percentile? So you could, if this was like an IQ test that you were taking, if you knew your IQ, what percentile were you in? So if you were a person who was 23 at the party, what is the percentile? So here's the formula here. Again, you'll get the formula, but you will not get what the letters are equal to. So the percentile is equal to 100 times L, which is the number of data that is less than the value. So less than 23, if we take a look at our data, there's 1, 2, 3, 4, 5, 6, 7 pieces of data that are less than 23. Plus 0.5 times E. E stands for the number of data that are equal to that value. So if we look at our data, how much data or how many pieces of data are equal to 23? Sometimes the answer is just 1. But in this example, 1, 2, 3, 4. 4 pieces of data are equal to 23. So that's 0.5 times 4. And it's divided by n, which is the number of pieces of data, which is 15. And when you calculate that, you get 60. So therefore, it's the 60th percentile. Again, just to go over what this means. So that means 60% of the people at the party are 23 years old or younger. And that's what a percentile means. So what you're going to do is you are going to try the next examples on your own. Press pause on the video, try them, and then come back to the video and check your answers. So press pause now, please. Okay, welcome back to the video. So hopefully you got these answers for your 5-number summary. Min 24, max 58, that's easy. The middle number, because there's an even number of data, you have to go in between the two middle numbers. They're both 32, so the median is 32. The lower quartile is the middle of the lower half. Once again, there's an even number, so it's in between 29 and 29, so Q1 is 29. The middle of the upper half of the data lies in between 42 and 44, so when you average those, you get 43. So that is the 5-number summary. When you drew a box and whisker plot, there was your min, Q1, median, Q3, and maximum. When you need to compare the second party to the first party, there's a couple things you want to talk about. First, we're comparing not the means but the medians. The medians is still considered an average, so you can say it's a median, but on average, the average age of the second party is higher than the first party. Another thing that you can say is that in both parties, the upper quartile or the fourth quartile is the most spread out. That means the top 25% of the ages are more varied than any other quarter. In the second party, you can also see that the lower half of the data is less spread out than in the first party. So you could say the ages of the lower half of the ages in the second party were more consistent than the lower ages in the first party. So these are the types of things you want to talk about when you compare two different sets of data that are similar. So you didn't have to rewrite the box and whisker plots here. I just did it here so as I explained. So I said the median age of the second party is higher here versus here. The ages of both parties are more spread out in the fourth quartile, so that's this section and this section right here. That means the ages of the older people are more spread out. The first and second quartiles in the second party are less spread out, meaning the ages of the lower half in the second party are more consistent because they're less spread out. Question number 4. When you were looking at the z-score for Amanda, it should calculate to approximately 0.29. So Amanda is approximately 0.29 standard deviations away from the mean. So who is statistically older compared to other people at their party, Amanda or Ganique? Well, Amanda's z-score was 0.29 and Ganique's z-score was 1.24. So Ganique's z-score is higher. That means she is more standard deviations away from the mean than Amanda is. That makes Ganique statistically older compared to the parties. So compared to Amanda's party and compared to Ganique's party, Ganique is older than the average age. Now, you might say that that makes sense because Ganique's age is further away from the mean because her age was 40 and the mean was 22 versus Amanda, whose age is 40 and the mean was 36. So you might say it's obvious that Ganique was older compared to the other people at the party, but it really does depend on the standard deviation, because if the standard deviation was much smaller for Amanda or much bigger for Amanda, then if it was much smaller for Amanda, then her z-score would have been much bigger, meaning that she might have been older compared to the rest of the party. So it's not just a difference between the age and the mean, you also have to take the z-score into consideration. So question 6, to find the 35th percentile, what you want to remember, it's 1 plus the percentile times the number of data minus 1 over 100, and that gives 6.25. The 6 is the I, and the 0.25 is the D. So I is 6, so this formula is y6 plus the decimal value 0.25 times y7 minus y6. y6 means which value is sixth in line, and y7 means which value is seventh in line. If you take a look at the data, the sixth value is 32, and the seventh value also happens to be 32. So when you work this out, the 35th percentile happens to be 32. So that means 35% of the people at the party are 32 years old or younger. Lastly, what percentile corresponds to the age of 50? So that formula is 100 times the number of people that are less than 50, which are 13 of them, plus 0.5 times the number of people that are the same age as 50, which is only one person, divided by the total number of people, which is 16. That works out to 84.375. So that is approximately the 84th percentile. So there's a lot thrown at you, but if there's anything that you don't understand about calculating the quartiles, percentiles, or z-scores, or how to understand them, please make note of it and ask your teacher in the next class. Thank you.